Okay, so this video is going to be an attempt to explain how Stammer works with the models like GPT-4 and how the knowledge base functionality works. And I say attempt because I'm doing this completely off the cuff and we're going to be doing virtually no editing. So we'll probably make a higher production quality video later on. But just keep that in mind. So first off, let's talk and make sure we have a model built up of what GPT is. So GPT-3, they are all what's called generative pre-trained transformers. That's what the GPT stands for. Now, the generative part, of course, refers to the fact that it generates text, right? Inherently, what this is one very large function, or at least you can abstractly think about it in that way. It takes in text, and then the function outputs text. And that will be important to remember later on in this video. The pre-trained part actually refers to the fact that these models are pre-trained on very large data sets. And of course, they have to be, right? Otherwise, you would have to do the training yourself. And then the transformer part actually refers to the fact that these are based on the transformer architecture. I believe that was originally developed in 2017 by Google, possibly with the BERT model. But the transformer part means not that it transforms text, which is what a lot of people online have mistakenly said. It refers to the fact that the model actually has the ability to dynamically change its focus based on what it thinks is important in the input text and based on the context that it sees there. So that's what these things stand for. But what I want you to remember is one key point. You don't have to remember any of what the generative pre-trained transformer stands for, but I want you to remember that at its core, this thing takes in text, okay, processes it, and then it generates text as its output. That is all it does, and that is all it has the capability of doing. And why am I mentioning that? Well, because there are other models that take in other inputs, but everything that goes to ChatGPT has to be in text form or ultimately gets turned into text form by a lot of the tools that are working with ChatGPT. There's no magic going on here. Now, there are other models that you may have had access to and may have used that take in other inputs, right? They may take inputs like images. They may take other types of inputs like sound, files, essentially, binary. But those are different models. ChatGPT, the one that you use through the ChatGPT interface, is GPT-4. Now, it does have other models mixed in that it accesses from time to time. It can generate images and it can analyze images, and I'm pretty sure those are other models. But keep in mind, everything has to be text, especially over the API that we use currently. Now, one of you was asking this weekend about using CSV files, well, really Excel files, in the prompt. And let's explain why that may not behave like you think it would and why you can't just dump a large CSV or especially a large Excel file into the prompt and have ChatGPT just use that. So let's quickly talk about what a CSV file really is, right? So a CSV, very old text file format. And if you're familiar with them, it of course stands for comma separated values. Now that means exactly what it sounds, right? Inside that text file, if you ever open it up inside a text editor, you're gonna see just a text file with commas that separate the values. And now, for many of you, that's going to be self-explanatory, right? But not all of you, because we all have different, computing backgrounds. But if you take that CSV and if we were to read it in and kind of throw it into the prompt, this is what it would look like to ChatGPT, right? It's not going to have any kind of structure that you would see if you open a CSV file in Excel. Now, that being said, CSVs are such a simple file format that as long as the CSV can fit into the prompt, ChatGPT can usually read it. at least in my experience. Now, I haven't tried, massive CSVs with tons of columns, but it should be, actually, I haven't tried that. I'll have to try that more. I'm not sure. It may behave unexpectedly, but often it seems to be able to at least read the CSV to some extent. So let's keep that in mind. And what you would need to do, actually, let me delete this box here because I just threw this together. In order for a CSV to be read, ultimately it had to be dumped into the prompt, right? So this would be the prompt. You would probably have something up here that says, take a look at this CSV. Oh, and you would have to tell it actually that it is a CSV. But yeah, you'd have to say something like, look at this data here and tell me X, and it could probably come up with an approach. Now, the key thing here is that if that CSV is over the token limit for that model, then none of this is going to work anyway. And CSVs can quickly get over the token limit. So let's talk about token limits. And first, let's talk about what a token is. So when ChatGPT comes with something called a tokenizer, right? And a tokenizer breaks up strings into different parts. And if you don't know what a string is just like it sounds, a string of text, right? And that's what a tokenizer does. ChatGPT, you can think of it almost as when it says, it only takes 16,385 tokens, you can kind of conceptualize that as kind of parts of words, right? So you can almost think of it as words. But if you really want to know the amount of tokens in a text, let me show you how you do that. So ChatGPT actually has a token counter. Here's their tokenizer. And we can just enter some text into here. Hello, world. And you can see this is made up of 3 tokens and 12 characters. Oh, and this is nice. It actually shows us where those token breaks are. So we've got hello as a token. You get the space world as a token. And then interestingly, the exclamation point is its own token. And what I want to do actually in this video, I want to get some CSV data. Let me pause the video, get some sample CSV data. Actually, I'll just get it from here because these CSVs can quickly take up the token limit. Let's scroll just because of the nature of that data. Let's take this, for example. This is probably going to be more tokens than we would expect. I could be wrong. I don't really know the behavior of their tokenizer. I mean, yeah, you see, you can see how many tokens it can quickly take up, and code itself actually takes up a larger number of tokens than you would expect. Anyway, regardless, if you ever want to count the number of tokens in something, you can use this token counter. And finally, let's go back to our Miro, and let's take a look at the token limits, right? So originally with GPT 3.5 that we've all been using for over a year now, the token limit was actually rather low, 4,096 tokens. And as you can see, with this tokenizer, I'm already at 338, which is a small amount of data. So you couldn't dump a massive CSV in there. Now that's using 3.5. 3.5 has recently, as of a few days ago, been upgraded to where it now has a context window. That is how big the amount of tokens can be in the text you send it. But really, that's a mouthful. And what you can think of the context window as is kind of its memory. And that is all the text you send it in an API call. So if you have a large history of messages, actually, let me show you something interesting here. So let me go to ChatGPT and let me show you something interesting that a lot of people don't realize about the ChatGPT interface and how it behaves, okay? So let's send it a message, right? Hello, how are you today? Okay, that message had a number of tokens in it, right? Now, what you can't see here is that there is also likely a default, what is actually called a system message that's being sent with it. I believe the default one used to be at least, you're a helpful assistant or something. So that's being sent as well in the background, and there may be other prompts that are sent with this, within this interface that I'm not aware of. But so that all gets counted in the token limit, all that other stuff. Now, one interesting thing here. So if you send too many, like if you were to keep adding messages and the tokens keep piling on, and you were to get to a point where you're over the limit for that token, for that model, what would happen is that API call would fail, right? So now you're probably wondering, if you're paying attention, how in this ChatGPT interface do I never get those API call failures? Well, what the ChatGPT interface is actually doing is as the number of tokens in the messages, the prior history of the messages builds up, it will start to automatically, within this interface here, drop those older messages. And that explains why some of you have mentioned that as time goes on, as a conversation in the ChatGPT interface goes on, maybe you put some key details inside an older prompt and ChatGPT starts to forget, right? It literally is forgetting because those messages are being removed, the oldest messages. Okay, so that's enough of the interesting facts here, but let's go back to this. So with the new GPT 3.5 Turbo that was released a few days ago, the context window is much larger. So if your CSVs are within that context window, you should be good. Now, with GPT-4, the context window has always been larger. It started out as 8,000, around 8,000 tokens. Actually, I think, oh, that's right. They had a 32K model that had a larger context window. But now with the latest release, it's up to 128,000 tokens, which is a lot. It sounds like a lot, but honestly, some web pages can easily be over 128,000 tokens, even though the web page is not that large. You got a lot of JavaScript in there. You've got a lot of HTML, which that runs up the token limit very, very quickly. So keep in mind, its memory size is not unlimited, right? And that will come into account more here in just a moment. So yes, you can dump CSVs into the prompt. That could be an approach you could use, but they can't be unlimited. And you'd have to maintain an idea of how many tokens that is. Now, we are building a token counter into the base system prompt that will help some there, but keep that in mind. And if you ever want to find these token limits, it's interesting that this is crashed, but let's reload this. And you can find them here. Just do a search and you should be able to find that. Now, let's talk about Excel files, right? Because one of you was asking about Excel files and why we can't simply support reading in Excel files like we do the text files, the PDF files, and the Word files, doc files, basically. So let's talk about what an Excel file actually is. And now, if you didn't know, an Excel file is actually an XML file stored, zipped up, basically archived in a binary format. And so if you were to simply open an Excel file in a text editor, this is kind of a representation of what you might see, right? It would be binary characters, basically unreadable. And it would be trying to show those to you. So we can't simply read it in. Now, there are some other kind of approaches we could do here. Let me show you kind of what that would look like. Okay, I added some images here. Now, what we really could do, if enough of you are interested in this, is that we could read in the Excel file and possibly create kind of a custom format like this. This is not a specific data format, but this would work, and we could display it as text to ChatGPT, put it into the prompt just like this. So let us know if enough of you are interested in this and think it would work. The thing you have to remember is it would still have to fit within the token limit. So that would still be a limit here. The other thing that you could do, and what I've suggested to many of you before, is to kit it in another format called JSON, which stands for JavaScript Object Notation. Now, JSON works very, very well with ChatGPT. It completely understands that format. It is a text-based data storage format inherently. The problem with JSON is that it's also very verbose, very explicit, which is great for a data format like this, but not great for staying within the token limit in some ways. So that is another option that you can actually do today. There are actually CSV to JSON converters. What you would want to do, of course, is convert your Excel file to CSV, right? Save it as a CSV, and then open it in a text editor, the CSV, copy it, and actually put it into a tool kind of like this, and it would output the JSON. Let's actually do this now. There's the JSON, format here. And then you can take this and put it into the prompt. Like I said, it still has to remain within the token limit, so that is a limitation there that will always exist. But because it's within the memory of ChatGPT, it would have access to all of that data. So that is an approach you can definitely use. Okay, and so hopefully that makes sense. And you guys in our Discord, feel free to let me know if you want me to go into more detail on any of these topics. Let's now get to the main part of this video. And sorry, this video is already getting long, but let's talk about how the knowledge base functionality works, because we're not using prompt injection like a lot of other tools use. We're using something much different actually, and that works much better because it's actually allowing ChatGPT to determine when it thinks that it should call the knowledge base. Okay, so let's get to that now. Let me scroll down here, and you'll have to excuse this yellow one here. This is actually a note to myself that I want to make a much, much more technical video that kind of goes over, vector embeddings and kind of the technologies we use under the hood, because that would be very interesting to some people. But anyway, let's get into this. Okay, so when a user types in a question into our chat interface, we take that question, like for example, when are the Stammer office hours? We take that question and of course we send it to ChatGPT. What you can't see, actually you can see it in some ways if debug mode is on, but we also send, your base system prompt with it. So all the instructions in your base system prompt. And then we also send some additional information, which you can see inside our other system prompts that we expose to you all. Except for the knowledge base one, you actually can't see that. But we also send information to ChatGPT about the knowledge base function. And we say, hey, here is this capability that you have. And here's how it works. And here's how you call it. And then inside the prompt, we say, here's when you should call it and under what circumstances. This is called function calling in ChatGPT. And it's honestly one of the killer features for ChatGPT because it gives ChatGPT a way to easily interact with other code and direct it like ours. And you'll actually see it. So in the GPT store, you'll actually see this defined as actions. They call it actions, and you're able to build up these actions that you can tell your GPT that it has the ability to go and do other things like call other APIs and stuff like that. So we send that information to it. We say, hey, here's the user's question. Here's all these capabilities that you have in order to answer that question. And ChatGPT actually makes its own determination that it should actually call the knowledge base in order to make sure that it has all the knowledge it needs in order to answer this question. Now, you may be wondering, why is this approach so powerful and how do many other tools do it? Well, it's so powerful because it allows the intelligence of ChatGPT to kind of drive the actions that you want it to do. Many other tools actually use prompt injection, and that's a very, very dirty approach. And I can kind of illustrate for you why that's a dirty approach by just telling you kind of what happens. So a lot of tools will actually run their knowledge base code, which pulls the results from the knowledge base, and we'll get to how that works in just a moment here. But they take those results, that text from the knowledge base, and then they just dump it into this prompt right here when they send it to ChatGPT. Now, if all your application, your AI application is doing, your AI agent, if all it's doing is answering questions all day, that approach works pretty good, right? You're just giving it the information from the knowledge base. It's always there available to it. But if you get into other use cases where it's not always answering questions, but actually taking actions and doing things, then that approach becomes very dirty, to be honest. You're always including the knowledge base results there. What if it's not doing that? What if it's trying to schedule an appointment? What if it's trying to, call another API in order to get some results? It's going to see those knowledge base results in there, and it's going to mess up and pollute the prompt. And so that is why we started using this approach. Also, we found it to just be much, much better overall. ChatGPT makes the determination when to call these things, and that's how our entire platform works in general now. So let's talk more about this. So ChatGPT now decides to search the knowledge base, right? Hey, always double check to make sure that you search the knowledge base unless you already have enough information to answer the question from what's in the prompt. So then what actually happens under the hood, ChatGPT calls a function, right? It actually lets our code know, hey, I want to call this function. Here's what I want to call it with, and here's the parameters for that function. And under the hood, we have your knowledge base stored inside a very fast in-memory vector database. So we search that database for the strings. When are the Stammer office hours for this example, right? And that database actually uses a semantic searching approach. So let's talk about semantic searching. Now, semantic searching is a search that is a match. It matches based on the meaning, semantic, right? So the meaning and the context of the words rather than just, an exact kind of word for word match, right? And before all of this, what we've actually done is we have generated what are called vector embeddings. And we actually use OpenAI to do this because we found it to be very, very good at this. You don't have to use OpenAI to generate the vector embeddings. But what we do is all of your knowledge base articles, when we first ingest them, we actually go through and generate vector embeddings for all the knowledge base articles. If you want to think of what those vector embeddings are, they're actually a vector, so it's kind of a list of numbers, essentially. And what it really is those vector embeddings define the relationships of those words to other words. And I'm probably butchering this here, but it allows it to know kind of what the meaning of those words are so that when we come back and we take this string that says, when are the Stammer office hours, we actually quickly go to OpenAI every time and generate the vector embeddings for that query as well. That's what you have to do in order for the semantic search to work. So we take the vector embeddings from this, okay? And then we have in here all these vector embeddings for this already. And then a bunch of math happens and we actually get the results for matches, okay? So when are the Stammer office hours? We find things that mean similar things, right? So like, here's an example. We could get a match that says, when are the Stammer office hours? ? And of course, keep in mind, this would include a bunch of the text after this and possibly the text before this. I would actually have to look and see if we include text before now that I think about it. But regardless, it would include a lot of the text after this. And then here's another one, another example. The Stammer office hours are a great way to. And then here's like a user comment or something that could also get pulled in as a document if you'd included that in your knowledge base in the first place. But the point is, we pull 3 documents currently that have strings within them that mean a similar thing or the most similar thing to what is being queried here, right? And then what we do is we actually return those results to ChatGPT, and then ChatGPT can use the data from that to intelligently summarize and come up with the proper answer. And then it returns a response to us, which we then use to return a response to the user. Okay, and that is it. That is kind of how the knowledge base works. And what we would need to do to answer the person's question about Excel files and really reading databases, because we are working on that capability, what we have to do is, we have this action available to ChatGPT that we send with it to search the knowledge base. We also have other actions available, for scheduling functions, and then also for saving leads, actually. And what we need to do is actually give an action to ChatGPT to do things like read an Excel file for the exact information that it's looking for, or to search a database, possibly a product database, based on maybe the text the user is sending it. Maybe the user is saying, hey, what size are these shoes in that you guys sell? And the guy would say the name of some type of name of that product, that shoe. And then what could happen is that ChatGPT could then use our database searching functionality to search the product database that the user has already uploaded all the information to. And it would pull that data. It would get only the data it needs, right, for that product. It could, pull a picture, an image of that. It could pull details like, what shoe sizes are available, shipping options. It could pull all of that cleanly and then access it and use it to answer the user's question. And you can see this kind of multiplying from there. We could have it call other APIs, answering what the weather is in a certain country. That's probably a bad example because I don't know if that's a real business use case, but we could, check shipping information, check other databases for stuff like that, all kinds of interesting things we can do. And that is what we are working on currently. We're giving ChatGPT the ability to cleanly pull information from other systems. And finally, I want to close out with, remember, all of this is all about the fact that at its core, GPT-4, ChatGPT, right? It is a text-based model. So it takes in text, generates output text. And that's why everything has to be like this. So hopefully this explains to you all, and sorry this video was so long. We may have to cut it up a bit, but like I said, this is just me just talking here off the cuff completely. We will make a better, higher quality video soon. And keep your questions coming. If you have any questions about any steps in here, let me know. We can make videos that go into that specific question.